We are going to simplify some expressions with the distributive property. This was your online assignment for, it was actually October 30th, but hey, I printed it back then. If you were not here for that, or if you were mentally not here for that, you should go to my YouTube channel and watch this video. I'm not trying to get subscribers or views or anything like that. I'm not going to make $1 million off of 4 views on 67 different videos. I'm just saying there are 12.5 minutes of me explaining how to do this stuff, and you need to know how to do it. So let's do these. You can ignore the fact that it says do not use any spaces, do not use any words, because this was an online assignment. But the words and spaces I would like to use with you are, please do not just watch these videos. Please get out a piece of paper. And I say paper because you can look at it after you've done it. If you need paper, I got lots of paper. So now we're a minute into this video. Let's do some math. One thing I recommend you do is, even though some of the problems are short, use this habit, use this to practice, and then do exactly what I do. I'm drawing this little arc because I'm telling myself I'm multiplying 3 times x, and 3 times x is 3x. If you need a quick, but why is that? And you're not going to click on that video, but you're on this video, well, then I'm going to show you. What is 3 times x plus 2? This is saying, hey, I have 3 boxes that each contain x plus 2. And if you're like, that's weird, I don't get it. Okay, well then here's a box, right? Inside of it, if we had x-ray vision and we could look inside of it, hang on, I'm not a very good 3D artist, so there we go. If you're looking down in the box and you can see, hey, there's an x, and there's 2 things that say 1 on them, what's inside this box then is x plus 2. And if I were to draw this box 3 more times, then I could just count up what I had, and I would go, oh, well, I have 1x plus another x plus another x, that's 3x. And 2 plus 2 plus 2 is positive 6. And then I would be done. But what if you have more complicated scenarios? And what if you happen to have a box? What if you happen to have a box and inside of it are negative x's inside of it? And then also -1, -1, -1. And what if there was another negative x box? Okay, well, the contents of this box is -2x minus 3. And then what if I told you I want, I don't just have 3 of those boxes. What if I said I had -5 of these boxes? You gonna draw that picture? No. This is why we need to go ahead and learn how to do this stuff. So let's zoom in here and let's finish this. So 3 times x, 3x, 3 times 2 plus 6. I mean, we obviously already did that because we, did the boxes, but still, now we've done it. And that's kind of what we're doing over and over. We're just going to get more complicated box situations. So I'm not going to write out all of these because I don't need to write out all these, but you could benefit greatly from doing so. So 2 times 3x, that's 6x. 2 times -4, that's -8. One thing that if you are still not getting it, when do you have a negative? When do you have a positive? That's something we need to talk about. You need to come up to me and say, I did not know, nor do I know how this is a -8. Because if you don't, that's an issue. The simplified form of this expression is -8x minus 20. All right, now we have one that's obviously much more complicated than the other ones, but take this piece by piece. We are multiplying these two. We're multiplying these two. We are adding them together, okay? So first step, 5 times 2x is 10x. 5 times negative 3, negative 15. Now, I mentioned that we are adding, but let's pause and not worry about that yet. Because what I want to do is go, hey, I'm doing 4 times 3x. And since that is positive, I'm going to write 12x. And I'm going to write you a note. If this had been negative, ... I would be subtracting. Okay? And if you're like, do you mean this? No, I do not. I mean, if the result of negative, here, in fact, if it had been plus 4 times negative 3x, that would have been negative 12x. That would be subtracting, okay? But we don't have that currently because we got a positive. Notice that I drew all the way through that positive, and I'm pointing to this positive because that was positive 4 times positive 3x, which gave me a positive result. If you're wondering why I'm taking such an emphasis here, is I would say that's been the number one problem for people. Positive 4 times positive 1 is just positive 4. And now I want to combine like terms. So 10x plus 12x, that's 22x. Negative 15 plus 4, negative 11. The next major problem people have been having, they're asking, they look at this, and they've been coming up with all sorts of different answers. They're coming up with negative 11, if they're right. They're coming up with 19. They're coming up with negative 19. They're coming up with just answers that I'm like, that's not at all what we have. You have negative 20. Put that through whatever thing that helps you remember. If it's you're feeling negative 15, okay, you've lost $15, or you're 15 feet down under. I don't care what it is that you have to go. This is the current situation that we're in. And then you are going to gain $4. That's one scenario. You're going to receive 4 compliments, or you're going to jump up. This was a J, awesome J, jump up 4 feet. Well, if you were negative 15 in any of those scenarios and you add 4, your final answer is negative 11. It's not enough to get you into the positive, right? Right. Next. This is one set. This is another set. 2 times 4x is 8x. 2 times positive 3, positive 6. Negative 3 times 2x, negative 6x. Negative 3 times negative 1, positive 3. Okay. So one thing before we move on is that a negative times a negative is a positive. If you need to, remember so 1, we've said that a million times. 2 is same signs, positive. These are the same signs, right? So they will end up being positive. Okay. Now up here, when I said if the result of this had been negative, I would be subtracting. Guess what? The result of negative 3 times 2x is negative. So I am subtracting now. Am I subtracting the whole thing? Not right now. I'm just subtracting this part. Why am I not subtracting the whole thing? Because I distributed already, okay? If you want to come back up here, and before we distribute, you could say, I am removing 3 boxes of this much stuff. Like if we need to draw a picture, you could say, hey, if I remove 3 boxes that have 2x each in them, well, then I would remove 6 x's total, right? And then just like, well, I was about to say just like, and then this, if I remove 3 negative 1s, that is removing, I'm sorry, that's like giving you positive 3. Removing negatives, removing insults is positive, remember? So now, combine like terms. We have 8x minus 6x. That's 2x. Positive 6, positive 3, that's positive 9. We're done. 3 times 2x plus 1, that's 6x. 3 times 1, that's 3. 2 times that, 2 times 3x, 6x. 2 times negative 2, negative 4. What am I doing here? I am adding. Why am I adding? Because this is positive. Okay? If it were negative, I'd be subtracting. But it's positive, so I am adding. Okay? So, 6x plus 6x, that's 12x. 3 minus 4, negative 1. I just remembered that as you're doing this assignment, they're probably shuffled, and so your number 20 might be number 1. So here's my advice. Write all of these down if you are struggling to that degree, or if you're not, then, scroll through, sift through the video to find the problems you actually need. So anyway, sorry about that. Negative 2 times this thing. Negative 4 times this thing. Why is it negative 4? Because there's a negative there, okay? So negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8. Negative 4 times positive 2 is negative 8x. Negative 4 times 1 is negative 4. Combining like terms, negative 14x, 8, and negative 4 is plus 4. Done. Next, 4 times 3x is 12x. 4 times 2 is 8. Negative 2 times 4x is negative 8x. Negative 2 times positive 1, negative 2 times negative 1, positive 2. Combining like terms, 12x minus 8x is 4x. 8 plus 2 is 10. I've sped up considerably on these last 2 problems, and this is kind of the pace that I plan to keep. If you are completely lost and you have not watched this video, please go watch this video. If you're completely lost and you've watched that video and you've watched this video, you need to talk to me, contact me, email me, talk to me in person, whatever, okay? Next, 2 times 3x is 6x. 2 times negative 1 is negative 2. Positive 3 times 2x is positive 6x. Positive 3 times 4 is positive 12. 6x plus 6x is 12x. Negative 2 plus 12 is 10. Negative 3 times 2x is negative 6x. Negative 3 times 5 is negative 15. Negative 5 times 3x is negative 15x. Negative 5 times 2 is positive 10. And sorry, I said just times 2. It's negative 5 times negative 2 is positive 10. Combining like terms, we have negative 6x and negative 15x. That's negative 21x. Negative 15 and 10 is negative 5. Okay, now we got some like word type problems, vocabulary type problems. The number in front of a variable telling the mathematician, telling you how much to multiply the variable by is called the, okay, well, let's take this for example, 2x plus 5. This is an expression. This is a constant. These are terms. And if you're wondering what's left, the number in front of a variable, telling you how much to multiply the variable by is. How many times are we multiplying that x? 2 times, because it is the coefficient. So if you are confused on what the right answer is, I'll put a star by it. Double star, squiggly underline, double circle. A number with no variable is called, well, hang on. Didn't we just do that? Didn't we just have a thing? So 2x minus, actually I think it was plus 5, but whatever. This guy's got a variable, so it's not the coefficient. These are both terms, so it's not terms. This is an expression, so what's left over is the constant. So again, double star, squiggly line, double circle. A constant, as I've tried to say in class, is like if I ask you to bring me $3, or if I ask you to bring me 3 markers, if I ask you to bring me 3 pizzas, there's no confusion on how many you should be bringing me, right? That's because 3 is a constant. Now, if I asked you for 3 boxes of markers, well, sometimes boxes can have 4 markers. They can have 12. They can have 108. That was a weird 108. That's when it becomes a variable, is when we don't know based off of how many is going to be inside. Okay, these have the same variable and can therefore be combined. What are these? Okay, well, if you have something with the same variable, like maybe 2x and 3x, they have the same variable. Is this the distributive property? No, not at all. What we've been doing is the distributive property. This is the distributive property. 14x plus 22, that's the distributive property, so that's not it. This is an expression, so multiple expressions, that isn't it. The additive inverse, okay, the additive inverse of 2 is negative 2, so that isn't it. Like terms have the same variable and can be combined. A blank consists of one or more numbers, variables, and operations. Okay, 2x plus 5. Hold up, let's make this more complicated. 2x plus 5, 7 plus 3x minus 9. And you know what, let's throw a 4 in there. That's what our assignments look like, right? Okay, a blank, a term consists of one or more numbers. A term is like one number. Okay, so that ain't it. A numeric expression, okay. Numeric expression would be like 2 plus 3 plus 4. That's a numeric expression. So this is not a bad guess, but it's the wrong guess. A variable is a single x or a single y or a single z. That's not it. It's an algebraic expression because it has variables. And if you're like, well, what's an operation? Here, I'll change it to purple. What's an opera? What's an operation? Plus is an operation. Plus is an operation. Minus is an operation. Those are operations. Okay. Fill in the blank. 4 times 3x plus blank equals 12x plus 16. Well, if you were to do 4 times 3x, you would get 12x. So the blank, what would have to go right here in order for us to get 16? The answer is 4. 4 times 4 is 16. This one's a little more like, okay. 3 times 4z, well, that is 12z, so that's good. But 3 times negative what would give you positive 21? It would have to be negative 7. That's the answer. And if that, the reason it's kind of like a is because there was already a negative there. And I know it's funky to say negative 7 after the minus, but I designed this problem so that you would have to think, how do I get a positive from something that's already negative? What's the coefficient of k? Well, coefficient, if you didn't pick it up from all this information up here, is basically the number. So coefficient is the number in front of the variable. Okay. And what's the coefficient of specifically k? Well, if you chose negative 4, I would say, oh man, that's not the worst answer, but that's k squared and not k. This is k. The answer is 9. I put that on there and that on there just as like traps because they're pretty bad answers. I put this on here and this on here because they're not terrible answers, but this one's pretty bad because that's a constant. And then this is like oh man, you answered too quickly because it's really this one. Stars and squiggles. What is the constant of this expression? Again, trap answers here because that's a variable, and constants are not variables. Okay, so is it 12? Nope, that's a coefficient. Coefficient. Is it 14? No, that's a coefficient. That leaves 24 because 24 is a constant number. What is the variable in this expression? There's a z there and a z there. It's because it's z. This up here had a y squared. So if you were being asked what's the variable up here, I could see why you might hesitate. You might think it's y squared or y, and you'd have a 50-50 chance. But here it's just z. There's a couple of 3's in the problem, but that isn't it. There's even a couple of 5's, but that isn't it. There's a 2 and a 9. Nope. It's z. Last but not least, if an expression, you mean like this? If an expression has no like terms, there are no like terms, then it is constant? No, that's constant. It's simplified? Not really sure what that is. It's variable? That's a variable. It's like terms? Well, if there are no like terms, then why would it be like terms? It's coefficient? No, that's a coefficient. So even if you have no idea what simplified means, maybe you just figured it out. It's simplified when you have no like terms because you can't do any more things. That's it. So I know this was a 25-minute video. I went into great detail trying to explain how to do some of this stuff. I'm everything short of begging you to just do these arrows with me. I know it seems stupid, but I have said numerous times that math is about organizing and communicating, and you are organizing and communicating when you use those arrows. At least that's my opinion. Let me know what questions you have about simplifying expressions, especially using the distributive property. See ya.